In this lesson, we are going to factor polynomials where the degree is greater than or equal to 3. So we're not just looking at quadratics anymore, but this video really is reviewing the same exact methods you've already learned. So why is it important to know how to factor? Well, how did we do it when we were, or why did we have to do it with quadratic equations? And the whole point was to find our x-intercepts or our zeros. If we're talking about motion, it's the point at which a ball would hit the ground. There's a lot of financial applications as well. We will look at additional examples as we look at polynomial functions, but again, it's still going to be finding the x-intercepts or the zeros. So we're going to factor these polynomials completely to remind you of the steps that we've always done. First of all, no matter what type of polynomial it is, you're going to look for a greatest common factor. So I notice in this first one that there's an x in all three. Leading coefficient's 1, so x is going to be the largest thing that I can factor out of both. So if I divide each by x, I would get x squared plus 2x minus 15. Now, potentially, this may factor further into two binomials since it's quadratic. We're going to do the tic-tac-toe method for this, so I put x squared, negative 15, and my checking term is 2x. X times x gives me x squared. My factors of negative 15 mean one's a positive and the other is a negative. I'm going to try 3 and 5. I'm going to put the 5 here because I recognize I need a positive 2. Negative 3 here. Multiply across gives me positive 5x, negative 3x. And I add to get 2x. So my factors are on the diagonal. One is x plus 5, and the other is x minus 3. This is my final answer. I know I'm finished because, well, each of my factors here is linear, so I can't break it down further. Make sure you don't drop your GCF. Recognize that if you multiplied back together, it would give you the simplified answer is what we started with. All right, on to the second. Again, looking for a greatest common factor. I check and see, does 2 go into both? They're both even, so I'm going to factor out a 2. And there is a y to the third in both places. So I'm going to divide everything by 2y cubed to begin. And that would result in y to the second minus 9, just minus 9. Now I'm hoping that you recognize this as the difference of two squares or the dots pattern. Difference of two squares. This is where, just bring down my 2y cubed, factors into two binomials. This is a perfect square. You take the square root of it, it's y. 9 is a perfect square. The square root is 3. The pattern is 1's a plus and 1 is a minus. Okay, there it is, completely factored. Number 3, again, looking for GCF. I see 4 goes into all three terms, and there is at least a z squared in both terms. I'm going to divide each term by 4z squared is what I'm doing. So that's going to produce z to the second minus 4z to the first, and then divided by 4z squared would be a plus 4. I now have a trinomial that may potentially factor further. If not, this would be as factored as it can be. But I'm going to check again by doing tic-tac-toe. Set up z squared, positive 4, and it needs to add to negative 4z. My factors of z squared would be z times z. Factors of positive 4 that add to a negative middle term means they both have to be negative. Again, I always told you this means the signs are the same. Same as what? Same as this, a negative. Factors of 4 would be 1 and 4, or 2 and 2. I'm going with 2 and 2. Multiply horizontally. Check it by adding. It does add to negative 4z. So my two factors are z minus 2 and z minus 2. If you feel like I'm going too quickly through this video, I would encourage you to return to our quadratic unit where I go through the problems in a much more careful way. But this should be a review for you. Okay, so 14t squared minus 21t. We're looking again for GCF. So I believe 7 goes into both 14 and 21 and t. So I will divide both terms by 7t to begin. That produces 2t minus 3. Now, I have a linear binomial here. Linear things don't factor any further, so this is it. Last two. Again, beginning with my GCF. So in number 5, I believe my greatest common factor is 2x cubed. I'm going to divide each of these by 2x to the third. And that will result in x to the fourth minus 16. So I have a binomial. That is the difference of squares pattern. This factors into 2 more binomials. Okay, so this is perfect square. Square root of that would be x to the second. Think about it, x squared times x squared would be keep your base and add your exponents, would be x to the fourth. Square root of 16 is 4. Pattern says 1's a plus and 1 is a minus. Now, look and see if you have linear binomials. We don't. We've got quadratic, so they potentially could factor further. This one is not further, cannot be factored further. It's not the difference of 2 squares. The dots pattern difference means minus. This one, though, is. It's a perfect square minus a perfect square. So I'm just going to recopy the first 2 factors. They don't factor further. But this one here is going to factor into 2 more. I'm going to take the square root of x squared. That would be x. The square root of 4 is 2, and the pattern says 1's a plus and 1's a minus. Now these 2 are linear, so it's not going to factor any further. It's all 3 of these factors, or 4 of these factors rather, multiplied together. If I would multiply all back together, I would get this 7th degree binomial that I started with. Okay, last one, number 6. So I'm checking to see anything go into each term. Well, I don't think there's anything greater than 1 that's going to go into 21, 20, and 25. So I'm going to jump right to tic-tac-toe. And this would be 21 x to the 6th. I need factors of negative 25, and they need to add to 20 x to the 3rd. Now, because I needed to add to x to the 3rd in the middle, I know that I'm going to need an x to the 3rd and an x to the 3rd right here. X to the 3rd times x to the 3rd is x to the 6th. Keep your base and add your exponents. All right, so factors of 21. Potentially could be 21 and 1, could be 3 and 7. I'm going to begin with 3 and 7, just my choice. I typically start with the 2 closest together. Now I'm looking for factors of negative 25. This tells me one's a positive and the other is a negative. I may need to switch those. I'm not really certain at this point. Factors of 25 would be 5 times 5 and 25 times 1. Again, I'm going to start with 5 and 5. We'll see if I need to switch anything. Now I'm going to multiply horizontally across. This would produce negative 15 x to the 3rd. And then 7 times 5 would be 35 x to the 3rd. And I add, to check it, this would add to positive 20 x to the 3rd. So there, I got it on the first try, using the tips that I've been teaching you all along. The factors then occur on the diagonal. It would be 3x to the 3rd plus 5, and then 7x to the 3rd minus 5. Now, the difference of squares works for perfect squares. Something to the 3rd power is not a perfect square. We will talk next about the difference of 2 cubes, but it would have to be a perfect cube, and these are not perfect cubes. So that's it. Okay, so this should be a nice review of the factoring methods you currently know.